Welcome back to the second part of marine propulsion. Diesel, electric, or hybrid? Hopefully this will be the last part. In the first part we talked about diesel propulsion and electric propulsion and discussed the different pros and cons in depth. In this second part, we will talk about diesel electric and hybrid propulsion. Again, like in the first part, using the 10 kilowatt or 14 horsepower at the prop example. There will be two short addendums about lead-acid gel AGM batteries and solar. After that, we hopefully can come to a summary and draw some conclusions. In the interest of brevity, I will not recap anything I already talked about in the first part, but I will refer to the first part a lot. So please watch the first part first. Card here, link in the description. So let's dive right in with diesel electric propulsion. The name is self-explanatory. You take your diesel and using a diesel generator, you make electricity out of that, which you use to drive an electric motor, which provides the propulsion. The idea has been around for quite a while. In World War II, Porsche tried to build a diesel electric tank. It didn't quite work out. For a while they were very popular in locomotives. Today you find them in these big oversized mining trucks and in some mid-sized ships that have special requirements for the propulsion. The main idea with diesel electric propulsion is to get rid of large cumbersome gearboxes and long annoying shafts that get into the way. In a marine application, you can place your generator wherever you want, aft, forward, midship. Of course, you need to run cooling water in it and you need to take care of the exhaust. The much smaller electric motor you can place, like with an electric drive, where you want, outboarder, classical with shaft in ports somewhere. So this is also one of the biggest advantages of the diesel electric propulsion. Let's crunch some numbers. We already know that electric motor from part 1. To give us 10 kilowatt at the prop at full throttle, it needs 10.9 kilowatts input. New is that diesel generator, and I'm using here a DC generator. It makes absolutely no sense in that application to use a generator that produces mains AC because we have a DC motor. And in my example, I'm using a Whisper Power MGV3 Plus that weights in at 240 kilograms and can crank out a maximum of 12 kilowatts. I didn't exactly find a 10.9 kilowatt marine diesel generator. And at 12 kilowatts, it consumes 277 grams of diesel fuel per kilowatt hour produced. Since we are only running that at 10.9 kilowatts, our specific fuel consumption is a little bit lower. Remember that specific fuel consumption curve for that Isuzu diesel engine from part 1. I corrected that down here just 5%. That gives us in total an endurance of 35 hours, which is 1 hour more than our pure diesel propulsion example. This is a wee bit eerie, but we have two things going here. First, the diesel engine in here is a wee bit bigger, it's a 3-cylinder, than our diesel engine we used in part 1 for the diesel propulsion, which was only a 2-cylinder. So it's probably a bit more efficient. Remember, also intro part 1, the bigger the engine or the machine, the more efficient it is. Second, maybe, that's speculation, the vendors of marine diesel generators optimize the hell out of their products. while the vendors of normal marine diesel engines are a little bit more conservative in their designs. That could, again, speculation, also mean that the lifetime of these marine diesel generators might be a bit shorter than the lifetime of a marine diesel engine. And the whole thing weighs in at 394 kilograms. Yeah, we already know that diesel tank from part 1 too. And that's just about 150 kilograms more than our pure diesel propulsion. Other pros and cons. It handles beautifully like an electric motor. No more fiddling around with the lever for the gearbox. It's a bit quieter than a diesel engine because these generators are usually encapsulated, but of course you still have the stink of the diesel exhaust. In terms of maintenance, comparable to a diesel engine, you still need to exchange the filters and change the oil here. Operational costs, also comparable to a diesel engine. Spare parts, oil, and you still have to fill up the diesel tank. Fuel economy being only marginally better than a naked diesel engine. Buying it? 9,000 for the electric motor, we saw that in part 1. That Whisper Power MG-V3 Plus comes to 17,000 and then add a few hundred for the diesel tank. As always, all prices in euro including German tax. Last but not least, the hybrid propulsion. Problem being, there is nothing like the hybrid propulsion. There are many different forms of hybrid propulsion. What I'm showing here is a series or serial hybrid where you take your diesel, make electricity out of that, store that electricity in a battery and use that to run an electric motor. Sometimes that's called a range extender setup because you have a pure electric drive which range is extended with some kind of diesel or other fuel generator. Other forms are parallel hybrid, where a diesel engine and an electric motor can drive at the same time your mechanical output, in our case the shaft and the prop. If the electric motor is very small, just replacing the starter of your diesel engine may be combined with the little generator to recharge your starter batteries. You call that a micro hybrid. Bottom line, you could make a whole video series about hybrid propulsion. And the only reason I'm showing you here this serial setup is because it's an easy transition from our diesel electric propulsion. Just add the batteries and you're done. It's not necessarily the best solution. Also, the numbers I'm showing here are totally unrealistic worst case. Any hybrid propulsion will perform better. However, they serve the purpose to show you the potential pitfalls of hybrid propulsion. Let's start with our electric motor again, which needs 10.9 kilowatt input power. And now we have the batteries, which we are no longer charging when moored, but charging from a diesel generator. So we have to take the efficiency of these batteries into account. And the thing is, if you discharge these batteries very fast, you only get about 92% of what you put in electric power out of electric power again. If you charge them very slowly, that might go up to 98%. So I've taken 95%. Bottom line, to get 10.9 kilowatts out per hour, we need to put in 11.5 kilowatts per hour. So now we are running our diesel generator at 11.5 kilowatts. It's not quite at its max output. So our bonus here for the typical fuel consumption is not 5%. I say it's 2%. It's arbitrary. And that leads us to 32 hours endurance, worse than the diesel electric or the pure diesel propulsion. Again, it's an unrealistic worst case, because if you run that, like in all our example, at full ahead, you could simply cut out the batteries and directly use the electricity from the generator, like in the diesel electric propulsion, to run your motor. And yeah, in that instance, you are at the endurance of a diesel electric propulsion. Hybrid propulsion starts to shine when we go away from our always full ahead assumption, which is a little bit unfair to the three previous examples, so I won't provide any numbers for that. The basic idea here is to operate your diesel generator always in the power band where it has the least specific fuel consumption. In case of our Isuzu diesel engine from part 1, that was a bonus of minus 10% compared to max output. Here at the diesel electric propulsion, we only achieved a bonus of minus 5%. And you do that by using the batteries as a buffer. If you're going full ahead, you let the diesel generator run at 70-80% output power and take the rest from your batteries to drive your electric power at a full 10.9 kilowatts. If you're only going slow ahead, you still let your diesel generator run at 40-50% of its max output and you store the excess energy in your batteries. With a hybrid, you could also do, like with an electric drive, recuperation. And you're also able to pre-charge your batteries when you are moored with land power. Buzzword here is plug-in hybrid. Bottom line, a well-designed hybrid system should give you a better endurance than just a diesel electric system. But of course, you need the batteries, which will add additional weight, so your weight comes up definitely higher than the diesel electric propulsion, and you have to buy these batteries. So you will also have to cash out more money when you are buying a hybrid propulsion. In any other aspect, they are very similar. I mean, you can run purely electric for a while, so you could say you have a little bit less stink and noise than with a diesel electric propulsion. On the other hand, it might be a little bit more complicated to design the whole system because, and I forgot that when I talked about diesel electric, you not only have to place the diesel tanks somewhere, but you also have to stack up batteries somewhere. So just another component you have to take care of. And here's a promised addendum about lead-acid batteries, and I will not have a look at the classic lead-acid batteries where the acid is freely sloshing around in the cells. Instead, we look at gel batteries where the acid is bound in form sort of a gel, and AGM, absorbent glass mat batteries, where the acid is absorbed in a glass mat. And I have here for you two examples from Active, the EDC 290 SA AGM and S-Gel. Both come in at 12 volts, 290 amp hours, giving us 3.5 kilowatt hours capacity. Both weighed in at 73 kilos, giving us an energy density of 21 kilograms per kilowatt hour. That's 6 kilograms heavier than the worst lithium-ion batteries I had seen ever. 430 euros. The gel is a little bit more expensive. That gives us a price of about 114, 120 euros per kilowatt hour. That's 5 times cheaper than the cheapest lithium-ion batteries I had a look at. Life cycles. If you fully discharge them, the AGM survives 300 cycles. The gel, a little bit more expensive, 350 cycles. If you discharge them only to 30%, that's not 30% charge remaining. That's you only taking out 30% of the 3.5 kilowatt hours. you can extend that to 1200 or 1600 cycles. Please note, this type of batteries deliver a whole lot of current, so 300 to 400 amps maximum continuous. Let's compare that to a lithium-ion battery from the same vendor, the LC300L LT, which comes in at a little higher capacity, 300 amp hours, so 3.6 kilowatt hours, and weights, well, not quite half, but almost half of these things, giving us an energy density of 11 kilograms per kilowatt hour, which is not the best, but also not the worst when it comes to lithium-ion batteries, especially LiFePO4 batteries. Watch part 1 electric drive again. 2,600 euros. That gives us 720 euros per kilowatt hour we have to spend. However, at 100% discharge, they survive 2,000 cycles, and at 50% discharge, they survive 6,500 cycles. But they can only deliver 200 amps continuous. That amps continuous number is something you should check for in your lithium-ion batteries. Assuming you can live with that weight penalty here of almost factor 2, and you don't mind exchanging the batteries every 350 cycles, you still need 6 of them to get to these 2000 cycles, about-ish. And if you multiply that kilowatt per hour price by 6, you're here at the same kilowatt per hour price, and you still have the weight penalty. You can juggle around the numbers as long as you want. You will end up with lithium-ion batteries, as all electric vehicle vendors have. That said, there might be some applications where these lead-acid batteries still shine. For example, these little electric forklifts in the big warehouses. They actually need a lot of weight in the chassis not to topple over. So why not take cheap batteries to fill that up and then never discharge them more than 30%? Or you have a big center console with 1 or 2 big gasoline outboarders that you use for fishing. And while you're out there, you run a little electric trawling motor, 1 or 2 kilowatts, just to keep the position. And then putting on 2 of these cells, 150 kilograms, that's probably okay. Second addendum, solar. I've taken here a random solar cell that is sold for boats, the Victron monocrystalline 360 watts, so 360 watts peak. It covers 2 square meters, it's 1 by 2 meters almost, weighs in at 23 kilograms and costs you 310 euros. In Palma de Mallorca, and for your non-European viewers, Mallorca is a nice little island in the Mediterranean. In July, we would get 0.59 kilowatt hours per day per 0.1 kilowatt hour peak installed solar capacity. And you can look up these numbers on various websites for various locations. So our 306 watt peak cell or 0.36 kilowatt peak cell would yield us 2.1 kilowatt hours per day, which we could use to run our 10 kilowatt electric motor for a little over 12 minutes. Or you could plaster your boat with 10 square meters of these cells and then you could run your motor for a full hour. Again, I'm not saying solar doesn't have its uses. I mean, with that capacity, you can run your navigation equipment, maybe even including a small radar, your navigation lights, your interior lights, if they are LED, no problem. Or you put 2 of these cells on and you could charge with that the battery of a small dinghy. More about that later. To summarize. And note, condensing all the stuff we talked in the last 40 minutes, including part 1 of this video about, to pluses and minuses, you necessarily lose some information. So please don't make any harsh decisions just based on this final table in the video. And also keep in mind, we looked at just one example that I choose and I might be, well, not might be, I'm definitely somehow biased. Let's start with the hard numbers, weight and endurance. And I'm including here recuperation because it influences the endurance, of course. The scales I'm using here, recuperation, you either have it or not. Weight goes from plus for the best system to minus for the worst system. Same for endurance. The diesel. The lightest propulsion option with a good endurance, of course, no recuperation. Electric, you have the choice. Either you take on a lot of weight to get a bad endurance, or you take on even more weight to get a mediocre endurance. Of course, that can be offset a bit by recuperating stuff. Diesel electric. Still good weight in our example. It was only 150 kilograms more than the diesel that came in at 240 kilograms. And you get the same good endurance as a diesel. Of course, no recuperation because there are no batteries. Hybrid is of course more heavy than diesel electric because it's diesel electric plus batteries. Depending on how many batteries you put on, it can be as heavy as an electric drive. But in return, you get a very good endurance. And yeah, the recuperation is one factor here that you can do. The other factor is, of course, you're running your diesel motor always in the power band with the least specific fuel consumption, if that thing is designed properly. The soft factors: handling, design freedom, noise, and smell. For design freedom and noise, I have the same scale as for weight and endurance. Smell, there is no plus because an electric drive doesn't smell like roses. Handling, again, like with recuperation, either you have to fiddle with that gearbox or you don't. The diesel, the worst propulsion system in these categories. Contrasted by electric propulsion, that is, if not a hyperdrive, but a dream drive. Diesel electric, still good handling. You have an electric motor that drives your prop. Design freedom is a little bit more limited than a purely electric system. You have to take care of that cooling water intake and the exhaust. Noise should be a bit better than a diesel because these diesel generators are usually encapsulated, and of course you still have the diesel smell. That leaves us with hybrid propulsion, which can improve in regards to noise and smell on the diesel electric drive, because for short periods of time we can propel our vessel purely electric. So yeah, a little bit better here. However, you have even less design freedom than with a diesel electric. You have to put those batteries somewhere, but still better than a diesel. Finally, costs, operational costs and initial costs. And I included maintenance here because it goes into the operational costs. Scale of maintenance, either you have to maintain a diesel motor or you don't. Operational costs, this time it goes from very bad to good. Very good would be running on renewable energies or sailing. Initial costs goes from very good to very bad being you are a billionaire, you can still afford it. The diesel can shine once again with the initial cost of just 6,000 to 9,000 for our 10 kilowatt example. Of course, later on you pay for the diesel and the maintenance, fuel filter, oil, etc. In contrast to that, you have to cash out upfront either a lot or a whole lot for electric drive, but you can recuperate that maybe over time via the operational costs and the non-existing maintenance. Diesel electric. More expensive, 3 or 4 times more expensive than a diesel, but still cheaper than electric and hybrid, so good. Of course, you have the same operational costs and maintenance like with a diesel engine. That leaves us with hybrid. which is necessarily more expensive than diesel electric because it contains a diesel electric setup plus batteries. And if you add a whole lot of batteries, it is as expensive as electric. You have to do the maintenance for that diesel motor, but operational costs should be lower than for diesel electric or diesel. And if you add a whole lot of batteries, you can use it as a plug-in hybrid and push those operational costs down even more. However, it will never be as cheap in that respect as electric. So, what can we conclude from all of that? Or again, what are my personal conclusions? If you are on a tight budget or you have very tight weight constraints, it will be a diesel. If you have a huge or unlimited budget and only very loose weight constraints and you can live with a very limited endurance, you can go electric and enjoy its benefits. You noticed something? 3 conditions have to be fulfilled, and for diesel it was 2, either or. So electric is really just for niche applications. As a commercial application, short-range ferry services come to mind. Just going over the river or over the lake or to the island just off the coast. You don't need a lot of endurance. You can recharge every time you're loading and offloading. And over time, you can regain your initial investment by the low operational costs. Or you're running a little barge in a harbor, giving tours to tourists. Same principles apply. My favorite non-commercial application, replacing that little 2.5 horsepower or so gasoline outboarder of your little dinghy with a 2 kilowatt electric motor and a little battery. 1 hour of endurance should be more than enough to get you ashore and back to your boat several times a day. It's a little bit more heavier. The outboarder may be 10 kilograms and that electric solution 20 kilograms. But, and I hinted at that before, you can reload that small battery easily with solar on your boat. And let's face it, that little outboarder never starts when it's supposed to. In my opinion, the decision to use a diesel-electric propulsion will always be a design-driven one. Let's say you want to build a tugboat with 2 Voigt-Snyder propellers somewhere midship, and your diesel for some reason has to be in the aft. Then you need a gearbox here, a shaft here, another gearbox and another shaft until you finally drive your Voigt-Snyder propeller. Why not replace all that crap with a diesel generator and just run a cable to an electric Voigt-Snyder propeller? These are commercially available, you know. The cost and weight difference to a pure diesel mechanical solution is probably not that large in this case. I don't think anybody will shell out 3 or 4 times as much for a diesel-electric solution just to reduce the noise and to get rid of the lever for the gearbox. If I had the money to spend and could stomach the weight penalty, I would probably put a hybrid propulsion with a smaller battery capacity into my pleasure vessel and enjoy all its benefits, including somewhat lower operational costs. But that's my personal opinion. There might be commercial applications where the higher initial costs for a hybrid propulsion might be regained over time by the somewhat lower operational costs. Again, we are talking ferries here, passenger crafts, whatever. We are definitely not talking freight, where every ton of your ship that is not freight you are paid for means you lose money. When it comes to freight, it's probably diesel all the way, and so we close the circle. Time to wrap things up. I probably forgot some very important aspects and I'm for sure got some things wrong, but you will let me know about that in the comment section, I guess. If the next time you see an advertisement for electric marine propulsion showing a 30-foot motor yacht speeding away on plane and you ask the right questions, what's the endurance of that thing and how many dead weight can it still take on? And these two videos are the reason for that. I'm happy. Till next time, bye.